Honorable President, Honorable Vice President, respected members of Scientific and Organization Committee, dear colleagues, ladies and gentlemen, it's a great pleasure for me to be accepted to participate in this international conference. My presentation, intitulated with a study on the nickel ferrite spinel for the removal of rose Bengal in aqueous solution under sunlight irradiation. Nowadays, a large amount of industries reject their wastewater in nature, which increase the risk of water contamination by these harmful rejects as textile wastewater. This kind of effluent contains color pigment, which causes cancer and other dangerous impact on aquatic life. Rose Bengal is an xanthonic dye very used in textile industries. It shows severe toxic effects on human life. It causes eye redness, blistering and reddening, itchiness, irritation and inflammation. So scientists try to eliminate this harmful reject from water using traditional water treatment methods, but it doesn't work. For this, they tried to use oxidation process or advanced oxidation process, which are based on the use of metal oxides as photocatalysts. So titanium dioxide, tin dioxide, zinc oxide and iron oxide are used to remove harmful rejects from aqueous solution. These semiconductors causes the total mineralization of the pollutant. The aim of this work is to develop a new low-cost, stable and active photocatalyst spinel using sol-gel method to degrade rose Bengal under sunlight irradiation. The nickel ferrite was successfully synthesized by a simple sol-gel method as a citrate nitrate. Obtained powder was calcinated at 300 and 600 Celsius for 2 hours and 3 hours respectively. So the characterization of the obtained sample was investigated using XRD diffraction, scanning electron microscopy, diffuse reflectance spectroscopy, and Fourier transformed infrared. For the photocatalytic measurement, the rose Bengal xanthine dye used as an organic pollutant model to examine the visible light performance and the degradation efficiency of the synthesized nanoparticle nickel ferrite spinel using sunlight as a source of irradiation, where 0.1 grams of the synthesized nickel ferrite was added to 100 milliliters of rose Bengal with the concentration of 10 to the power minus 5 moles per liter. For the characterization of the samples, XRD pattern showed the crystallinity and the phase purity of the synthesized spinel, or the peaks showed in the figure 1 are well indexed in the cubic phase with the space group FD3M. The highest peak refers to 2 theta equals to 35.63 with the HKL index 311, represented the formation of the nickel ferrite crystalline phase. The Fourier transformed infrared spectra showed the formation and the presence of metal oxides in the range of 515 to refers to the nickel oxide, and for 1400 refers to fair oxygen vibration. So the FTR spectra confirmed the formation of the synthesized nickel ferrite. The morphological analysis was investigated using scanning electron microscopy, where the morphology of the prepared sample are in nanometric scale, as illustrated in figure 3. The average size of the agglomerated nanoparticles was between 14.3 nanometers and 15.7 nanometers, with a uniform distribution of spherical nanoparticles. For the measurement of the band gap or the determination of the optical properties using EV visible reflectance diffuse spectroscopy, as shown in figure 4, the band gap energy of the sample is calculated using Dock equation. So the reflectance data of the adsorption coefficient as an extrapolation of the linear curve by plotting cubic alpha h nu versus h nu is used to calculate the band gap energy of the synthesized nickel ferrite. The obtained results show that the energy of the gap or the band gap of the synthesized nanometric nickel ferrite spinel equals 1.158 electron volt. The photocatalytic performance of the synthesized nickel ferrite spinel was investigated for the degradation of rose bengal in aqueous solution. Obtained results are mentioned in figure 5, where about 80% of rose bengal was removed after 2 hours of sunlight exposition. The degradation kinetic, as illustrated in figure 6, the linear fitting of minus ln C exposed C0 times for rose bengal dye flows pseudo first order kinetic behavior as shown in figure 6, where K equals 0.1939 minutes. So the graphical abstract or the mechanism of the degradation: sunlight causes the excitation of our semiconductor, which causes the formation of the free radicals O point and IHO point, and cause the total mineralization of the organic dye. The nickel ferrite spinel was successfully synthesized by sol-gel method. Crystalline phase analysis by XRD diffraction confirmed the formation of the cubic nickel ferrite. The particle size and the morphological analysis were investigated through scanning electron microscopy images, which clearly depict a narrow dispersed and spherical-like geometry of prepared nanoparticles. Diffuse reflectance spectral results esteem the significant training of optical band gap, which equals 1.158 electron volt. Nickel ferrite spinel nanoparticle exhibited excellent photocatalytic efficiency through the degradation of rose bengal under sunlight radiation, where about 80% of organic dye rose bengal was removed from water after 2 hours of sunlight exposition. and thanks for your attention.